Okay, so Scuba Steve swimming in the Edmonds Underwater Park, 70 feet per minute, direction angle of 310. So I've labeled that as the red part of the diagram. Here's Scuba Steve. He swims 70 feet per minute, 310 degrees. The diagram is actually provided in the problem. I'm going to get those labels on there. Due to the action of wind, tides, and ferry boat motors, the current in blue is already was labeled on the diagram. 45 feet per minute, the direction angle of 255. So the vector is drawn, but the labels I wrote on here myself. Um, the first question I need to establish is there a right triangle in this problem? And in order to find out, I mean, it doesn't look like it, but you can never trust math teachers and their diagrams. So I'm going to take the direction angle of the red vector and the blue vector. I'm going to subtract them. I've done that right here to find the difference, which in this case was 55 degrees. Um, yours probably will be different. 55 degrees is not a right triangle, so I would select no. Next question. Well, since there is no right triangle, our only option to proceed is to find the components of each of those two vectors and then add them together. So we'll start with the Scuba Steve component. So to find the x component, I'm going to take the magnitude, which was 70 feet per minute, and multiply it by the cosine of the direction angle, which is 310. So I got 45 feet per minute for the x component. The y component, uh, magnitude times sine of 310, so I got negative 53.6. I've rounded those to the nearest tenth as indicated in the directions. And then I would type into that answer blank those two components using pointy brackets and a comma to separate them, x first and then y. So I've got my color-coded circling going on here, but that kind of gets in the way of what you would be typing. So then we're going to do the same idea here with the current. I need to find the x and the y components. So the magnitude is 45. X component, I'm going to use cosine of the direction angle 255. The y component is 45 times sine 255. And again, I'm going to get these color coding circles out of the way. So you're going to type that answer with pointy brackets and a comma to separate them, x first and then y. Don't lose your negative signs if you've got negatives in there. All right, the next part asks us to add together the two components forms vectors. So the two green x components, 45.0 plus negative 11.6, gave me this x component for the resultant force of 33.4. Add together the two y components in the purple circles, negative 53.6 plus negative 43.5, and that is where I got this. I lost my negative sign. That is where I got this negative 97.1, but it does need to actually keep that negative sign. Sometimes negative signs go missing, it's a rogue negative sign. You're like, I swear I wrote that down, but then it's gone. Well, keep track of your negative signs. All right, then I need to find the magnitude of the resultant. To have the component form, once I get those two components, I can use the positive 33.4, negative 97.1 to find the magnitude. So here, that negative sign doesn't actually make any difference because I'm squaring it. And so whether I have the negative sign on there or not, when I square it, I'm going to get a positive number when I square it. At any rate, the square root of 33.4 squared plus negative 97.1 squared gives me 102.7. That is my magnitude. Okay, last part asks us to find the direction angle. What direction angle will Scuba Steve move as a result of these forces, meaning the swimming force and the current force? Give your answer as a direction angle of the resultant, round to the nearest whole degree. So I'm going to redraw this diagram, just let you see everything up front. So I want to draw the diagram just with the resultant on here. So I've got my x component, the 33.4 is the x, is going to go to the right. The y component, negative 97.1, is going to go down. So I have the components drawn correctly, and then I've got just the resultant. So I'm leaving out the swimming force and the current force, right? This is all I want to see. Okay, so when I set up my tangent ratio based on the perspective of Scuba Steve, I get the adjacent side, that's the x component, the opposite side is the y component. I am actually going to get rid of this little negative sign right here because if I put the negative sign in there, the calculator is going to try to figure out the direction angle for me, and calculators don't know the whole picture. It's just going to do the best it can, but I'm not going to trust it. I'm going to use my brain because I trust that a lot more than my calculator. Okay, so I set up my tangent ratio, 97.1 divided by 33.4, and then I had to do the inverse tangent of that ratio. When I do that, round to the nearest whole degree, I got 71 degrees. Okay, so inside the triangle I have drawn here, that little theta right there is 71 degrees. Okay, so direction angle. I know the direction angle is measured from the positive side of the x-axis. I'll highlight that. And the rotation direction is going to go counterclockwise, right? So just pretend if I was to go from the positive side of the x-axis all the way around to the positive side of the x-axis, that'd be a complete circle of 360 degrees, right? But I'm not going to go all the way around. This part inside the triangle, I'm going to omit. So it's like a full rotation of 360 degrees minus that 71 degrees. So my direction angle, I have to subtract. I'm going to get 289 degrees. That is my direction angle.